This lab has been put together to support your learning on statistical functions as well as the normal distribution. We're going to start off with the introduction to statistical functions in Excel and calculating descriptive statistics for a sample as well as population parameters in Excel, and compare the variability and consistency in data sets. The first thing that you need to do is go into D2L in the computer lab folder for this topic and download the data file and save it appropriately. And what I'm looking for is for you to save it as something that includes your first name and last name, as well as the lab. Okay, so make sure to include a header on the first worksheet. Okay, when you download your worksheet, it should look like this. And to include a header, I want to change it so that you have your name and stats and normal distribution lab. Okay. I've set up this lab to include various different worksheets that include the data in them. Okay, so looking back to the explanation, we have built-in functions in Excel. So similar to what we were doing in the first 4 Excel labs in this course, we made calculations. Every single one of the calculations that we're going to perform in Excel include equal signs. So you'll see here they all include equal signs. And all these functions are built into Excel similarly to how your calculator works, where you have a built-in key to enter in the data for a data set and then calculate the average and the standard deviation and variance. We will be doing the same thing in this course in Excel. So if you take a look at these formulas, the first formula for the mean includes an equal sign and then average and then an open bracket and then a closed bracket. Within those brackets, you'll put cell references for your data. Okay, and that's the same thing for all these sets of brackets, that you will want to include cell references for your data. So let's head over to the spreadsheet and calculate the average of the values in the data set. The first thing that we should identify is whether or not our data set is a sample or a population. And I'm going to tell you for this one here, it's a sample, and it's a list of times, average times to open or to load a web page. And we can see they range from values in cell A5 up to A36. Okay, so when we calculate the mean, our formula is going to be equals average. And as you start typing in the functions in Excel, you can see a drop-down box populates all the different built-in functions in Excel. Once you have the one that you want, you can open a bracket, and we're going to highlight the values from our data set. So we said it went up to A35, so we would expect that when we highlight them, it gives a list from A5 to A36. The colon in between means that it's a list from the first cell to the last cell. You can also use commas if you want to only list a couple of values. And when we press equals, we see that the mean value is 0.7. Then to calculate the median, we use equals median and an open bracket with the reference to all the data sets. So equals median, and we want A5 up to A36. And you can see as I type in the cell references, my data is highlighted to show me what I'm calculating with. Okay, it's also 0.7. To calculate the mode, equals and mode dot mult. Well, we can calculate a single mode from A5 to A36. It says it's 0.4. Other thing you can do is calculate multiple modes. So if there's more than one mode in your data set, you can highlight several cells and type in equals mode dot mult, which returns an array with if there's multiple modes. So A5 up to A36. The only difference with mode dot mult is that you need to press Control Shift Enter to analyze and fill the array with the multiple modes. If there was only one mode in your data set, the other function would have been appropriate, but we can actually key them in here. So we have 0.4, 0.9, and 0.7 are the three modes. I'm going to change it so they're listed in order. Okay. By definition, the range is the difference between your maximum value and your min value. And in Excel, we type it as equals max with the cell references. That selects the max value in all those cell references. And then we subtract out the minimum value again with a cell reference. So equals, remember to always start with an equals, max of A5 up to A36 minus subtracted the minimum value of A5 to A36 and press enter, and we find that the range is 1.1. Okay. The reason I had you identify whether or not it was a sample or a population at the very top of the spreadsheet is that the formulas for standard deviation, variance, and coefficient of variation are different depending on if it's a sample or a population. Looking at our table of built-in functions, you can see that for standard deviation we have STDEV, but then there's .p when it's a population parameter, and it's STDEV, so standard deviation .s, for sample statistics. The same thing holds for variance, where it's var.p and var.s for the variance of a population versus the variance of a sample. And when we find the coefficient of variation, which again is used to compare the variability in a data set if you have a different average, so it's the variability respective to the given average for that data set as a percentage. So it's different if you're using it for a population or for a sample. You have to make sure that you have the correct .p or .s listed. Okay, so since we are calculating these things for a sample statistics, we want to use the .s in all our calculations. So the standard deviation, we will say STDEV.s for the sample of our values from A5 to A36. And for the variance is var.s from A5 to A36. And the coefficient of variation is equals, so it's your standard deviation, STDEV.s for the sample standard deviation. Actually, you could use cell referencing for this, but I can show you that after, and you'll get the same value. So the standard deviation of the sample from A5 to A36 divided by the average from A5 to A36 and multiply by 100%. percent. Make some room here and make sure that we include the percentage symbol. Okay, so now we found all the statistics for our sample. One thing that we have left to do, I'll show one more thing first. So if you want to calculate the coefficient of variation using the statistics that we've already calculated, you can say equals and take your standard deviation, divide it by the mean that we've already calculated, and then multiply it by 100. And you can see that we get the same value as when we redo the cell referencing. Okay, and just for completeness, I'll record our units are seconds, 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 except for the variance, which is seconds to the power of 2. Can actually format this to be a superscript. And the units on the coefficient of variation are percent. Okay. In the lab, it has rounding instructions, and it's the same instructions that we use in class. So for the mean, we want to have one more decimal place than the raw data. And for the standard deviation and variance, you want to round to two decimal places, 2 more decimal places in the data. So our original data set includes 1 decimal place. So when we round our values, format the cell, you right click on it, go to number, go to decimal places, and we want to include 2 decimal places. Whereas for the standard deviation and variance, we want to have 2 more decimal places than the original data set. So originally it has 1, so we'll include 3 decimal places. So format cells, number, and select 3 decimal places. And all of those values have now been rounded. Okay. If you like, you can also round the coefficient of variation to 2 decimal places. It's really a matter of preference. A lot of our percentages in this course have been rounding to 2 decimal places. Okay, so that's the example for the intro statistics. And I'm going to start a new video for the normal distribution of a data set.